In this lesson, we will look at synthesis reactions. And synthesis reactions are ones where two substances, either elements or compounds, combine to form one new product. So we can really see this as being the opposite of the decomposition reactions. And you'll see that many of the reactions are exactly the opposite as the ones that we've looked at. The first group that we'll look at are ones where we have a metal and a non-metal forming a binary compound. So for example, if we combine sodium and chlorine, sodium is Na, chlorine, because it's part of Hofbrinkel, is Cl2. And when we join those and synthesize a new substance, we'll form sodium chloride. And to find the formula of the product, we need to do the crossover method. So we take Na plus and Cl minus and cross over. We never want to just put the two pieces together. We need to separately determine the formula. Iron plus oxygen, so iron is Fe, oxygen is O2 because it's part of Hofbrinkel, will produce iron 3 oxide. And so for this, you'll see with the iron, I need to be told what the charge on the iron is going to be. I properly write the formula and I balance the equation. And we'll practice that shortly. So you can see in this visual, and you've seen this reaction before, where we have magnesium metal reacting with oxygen. The magnesium atoms combine with the oxygen atoms to form magnesium oxide. Now B and C refer to acids and bases, and it's the opposite to the decompositions that we were looking at before. So when we decomposed an acid, we produced a non-metallic oxide and water. So if we go the opposite way, if we start with a non-metallic oxide and we add it to water, it will produce an acid. Now with these ones, knowing what the acid will be is a little bit tricky, so you'll be given information about the anion. So I would tell you that the anion you need is sulfate, or I would tell you that you're producing sulfuric acid. In some way, you'll be given information about the anion. You need to know that you combine that with the H+. For a metallic oxide, or a metal with oxygen, like calcium oxide or sodium oxide, when you combine that with water, you will produce a base. And so to make this compound, you're going to join the metal ion with hydroxide. The last ones are metallic oxides or ionic compounds combining with a gas and will produce an ionic compound. So these are the opposites to the ones we looked at last time when we had a chloride reacting with oxygen. That's what was formed when we decomposed a chlorate. Okay, so these are just the opposite, and we'll do some practice. So you have a metallic oxide with carbon dioxide, you're going to make the carbonate. So these are the things summarized that you need to look for. So we're always going to be looking for Hofbrinkel. We're always going to use the periodic table to figure out the charges on the metals so that we can properly write the formula of the ionic compound. And these are our little rules. If you have an oxide plus CO2, you're going to make a carbonate. If you have a salt plus oxygen, you're going to make a chlorate. If you have a metallic oxide plus water, you're going to make a base. And this should be non-metallic oxide. With water, you're going to make an acid. So let's look at some examples here. We have barium oxide plus CO2. So I have an oxide plus CO2, so I'm going to make a carbonate. So I'm going to take the metal ion plus carbonate, so Ba2 plus and CO3 2 minus. So if I join these two ions, I produce BaCO3. The balancing for this is straightforward. I don't need to actually do anything because there's 1 barium, 3 oxygens, and 1 carbon. For this next one, NaCl plus O2, So I'm reacting a salt, which is an ionic compound, with oxygen. So I'm going to produce the chlorate. So I'm going to take my metal ion plus ClO3 minus. I'm going to join those. I need one of each. I have 3 oxygens on the right, 2 oxygens on the left. So I'm going to need to put a 3 here and a 2 here, and that will make it so I need 2 NaCl. Radium is reacted with chlorine, so I need to start with the proper formulas. So radium is a metal, so it's just Ra. Chlorine is part of Hofbrinkel, so it's Cl2. And so I'm going to, on the side, determine the formula of my product. So I need the ionic compound, radium chloride. Radium's in group 1, so it's Ra plus, Cl minus, so I produce RaCl, and now I need to balance. So I've got 2 chlorines, so I need a 2 and a 2. Calcium oxide is mixed into water, so when you mix a metallic oxide into water, we produce a base. So you need to take the metal ion and join it with hydroxide. So I have Ca2 plus and OH minus. So when I cross over, I get CaOH2. I'm sorry. So I have CaO plus H2O. So my calcium oxide was Ca2 plus and O2 minus. Join that to produce my calcium hydroxide. To balance this, I look, calcium is balanced, hydrogen is balanced, oxygen is balanced, so I'm good.